Good morning. I saw a recent video by someone from a flat earth advocate telling me that I should go out and take measurements of the location of the sun to submit data for a collective flat earth data project so they could try to find calculations for where the sun is, try to build a model. And I thought, well, that gave me an idea that I could go out and take a measurement. But so I've got here a board with a nail in it. Well, it's not a nail, it's a punch, and I've set the punch so that it's 3 inches up off the board. You see, there we go, 3 inches up off the board. And the reason I chose 3 inches is because they tell us, well, many flat earthers tell us that the sun is 3,000 miles high, so I thought this would make my measurement a little easier if I make it 3 inches, because what I'm curious about is to try to figure out where's the sun right now on the flat earth model. So I put a level on my board here, pretty close, and made a little diagram to help you what I'm looking at. Kind of a classic proportional triangle problem. There's a shadow cast by the peg on the board. And then over here, there's a point somewhere off in the distance where the sun is directly over at noon, and it's straight overhead. It must be like straight up and down, 90-degree noon. And then the other side of the triangle is the altitude of the sun. So if we know the altitude of the sun, we can set up a proportion and figure out how far away that is. So let's take a look at what we've got on my board here. Again, that's a 3-inch peg. And let's take a look at how long our shadow is. Oh my goodness. The shadow, is the camera gonna pick it up? It's struggling, the camera is struggling to pick it up. There it is. All right, the shadow goes all the way out here. 18 inches. So I've got a 3-inch, 19 inches, sorry, I've got a 3-inch peg casting a 19-inch shadow. So we can do the math. See if I can hold my phone and do the math for you at the same time. Where's my pen? All right, so we do the math like this. If a 3-inch shadow, or 3-inch peg, cast a 19-inch shadow, then we can come over here and figure out that a 3,000 mile sun is going to be how far away. So we're going to take 3,000 times 19. Oh, that's going to be a very big number. Well, 3,000 times 20 would be 60,000. So that's going to be 57,000. My phone is also my calculator, so I'm not. I'm just doing it manually here. And then I take that number, right, and proportions, right? You multiply it this way and divide by the other number. So I take 57,000 divided by 3. Oh. So what's that going to be? Well, the math is pretty simple. That's why I chose the 3,000, because when you divide it by 3, it gives you 19,000 miles. So the sun is 19,000 miles away from me, according to the flat earth model. Oh, now the shadow's up, you can see it a lot sharper now. The sun is, the phone still doesn't like it. Okay, so the sun has got to be 19,000 miles away from me, and it's got to be, I took a compass reading on the sun, and it's about, again using my phone, sorry I can't show it right now, but since it's here on the 21st of June, 22nd, what is this today? The 23rd of June at 23, we're at the 23rd of June 2018, we're about 41 degrees north latitude. So I wish I should have brought out a flat earth map so we could try to figure out, and my marker goes through. But let's just think, if that's the North Pole, that's the flat Earth, and so that would be the equator, something like that, and we're about right here. Due west would be apparently that way, so we're a little bit north of that. So the sun is 19,000 miles this way. Somewhere over there. Well, the whole thing is supposed to be how far across? 25,000 miles across. And here, from this point, the sun is 19,000 miles that way. I don't know, Flat Earth folks. It doesn't make much sense to me. Try again.